Morning students, this is Anjali Diwalkar. Today I am going to teach you about resolution of forces. Okay. Please look at this screen. I'll tell you how to resolve force. Resolution means what? First of all, I'll tell you. If one inclined force is acting on the body with some inclination, say its magnitude is P and its inclination with horizontal is say theta, then what will be the effect in this direction and in this direction we are going to learn. So this component will be nothing but a P cos theta and this will be nothing but a P sin theta. Right. So this is nothing but a perpendicular resolution. Resolution means what? We are going to work out the components of the forces along some specific directions. So there are basically two types of resolution. First is a perpendicular resolution and another one is a non-perpendicular resolution. In a perpendicular resolution, we used to find out the component of a given force along x-axis, along y-axis. If a P is given to know whether it is in a clockwise, whether it is in a positive direction or negative direction, we have assumed some sign conventions related to that. I'll tell you. These are our sign conventions. You can use a different one also. So if a force is going upward, if a force is going leftward, and if force is having clockwise moment, all these things are positive as per my convenience. And if this opposite to that, force is downward, force is leftward, and it is having anti-clockwise moment, then those are the negative. So these are my sign conventions. So accordingly, again, four quadrants are also there. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. Right? First, second, third, fourth. Okay. Then we know that x in this quadrant is positive. So a component along x-axis is a positive, along y-axis is also positive. Along x-axis it is positive, but along y-axis it is negative. Here both will be negative, and here x will be negative, but y will be positive. We must remember this thing and also this thing. So I'll tell you ki it's a cup of tea for you, and you all are supposed to mug up these things, right? Then we'll move on. How a force components means how in which direction if it is acting, how much components will be there. So just for that, I am placing these many forces over here. So this is a P, Q, S, T. I'm avoiding R because as per our convenience, it is known to all of you must be knowing that a resultant is also there. So we used to denote it by R. So unnecessary to avoid confusion, I have mentioned it as a I haven't taken it as R. So theta, here theta is there, and here I'll take as alpha, here gamma, here beta is there. Purposefully, I have taken few inclinations with horizontal, with the vertical, right? So we are supposed to remember it. So two components will be like this. This is P cos theta, P sin theta. And for this force, again, two components. Depending upon the directions, we are supposed to take the two components. So this will be, do remember this, cos beta. The angle, if the angle is given with vertical, then vertical component will become cos and remaining will become sin. We must remember, if the inclination is given with horizontal, we are supposed to make a horizontal component as a cos. If inclination is given with the vertical, then our vertical component will become cos. Simply two components will be here. Yes, cos gamma. Yes, so here sin will be. Yes, cos gamma will be here. Sin and cos. Then again, two components will be like this. This is nothing but a T sin alpha, T cos alpha. Hope you understood, because this inclination is again with vertical. So vertical inclination will be, or vertical component will be cos. I'll draw one more diagram which will tell you how to resolve the forces. Now these forces are going away from your joint. Now I will draw some forces which are coming towards joint. This is just for understanding purpose. How to resolve must be known to you. Right? So again we'll name the same P, Q, S, T. 4 forces are there. Then now the directions will be like this. Please concentrate on this. It will clear your all doubts. There will be a confusion in your mind in which direction is to be assumed or which direction is to be adopted just to resolve the forces. So you can, if a point is going or a force is going towards your joint, then components also must be acting towards your joint. So this component will be P sine theta 1 and this will become P cos theta 1. Horizontal will become cos because inclination is with horizontal. And for this, inclination is again with a horizontal. So P cos theta 2, P sine theta 2 will be there. Okay. Likewise, inclinations will be there. Okay. I'll write down for this also Q sine theta 3. This will be Q cos theta 3. Why? Because inclination is with vertical, so vertical component will become cos. And here also S is there, so S cos theta 4, S sine theta 4. Likewise, we are supposed to resolve the forces. This is what is about perpendicular resolution. If a force is to be resolved, if this force is given to you and I want the effect in this direction and in this direction, again, what shall I do? The inclinations must be known to you. This is theta, this is alpha, say, right? Again, this is a P, Q, and S. What you are going to do here? You are supposed to either complete it a parallelogram or what you can do, you can apply Lambda's theorem over here. Here I will tell you how to complete the parallelogram. In next video, I may tell you about the Lambda's theorem. So what you are supposed to do, you are supposed to draw a parallel to this. You just extend this line, draw a parallel force like this, name it as a P. So now we do have this triangle. So if it is alpha, this will also become alpha, and this will become 180 minus alpha theta plus alpha. Am I correct? Then now you can use this Lambda's theorem over here. Q divided by sine 180 minus theta plus alpha, which is equal to, this force is nothing but a S. So S divided by sine alpha, and that is equal to P divided by sine theta. This is nothing but a Lambda's theorem. By using this theorem, you can work out the component of a force in a non-perpendicular way also. Okay, that's all from my side for today's video. Happy learning.